Today we're going to learn about dividing polynomials. So in order to do that, we're going to start with a warm-up problem with multiplication, and then we're also going to use long division normally to divide 213 by 4. So let's start with multiplication. Okay. So if I do have 2x plus 3 times 4x squared minus x plus 2, I kind of refer to this as double distribution, right? Because we got to multiply the 2x by each term in the other polynomial. So 2x times 4x squared is 8x to the third. And then 2x times negative x is negative 2x to the second power. And then 2x times 2 is positive 4x. Okay, so this is double distribution, so we have to multiply both 2x and 3 by each term in the other polynomial. So this is going to be 3 times 4x squared, which is going to be 12x squared. Notice how I'm setting it up underneath the other x squared term because they are like terms, so we're eventually going to combine. Then I'm going to take 3 times negative x, which gives me a negative 3x, and a 3 times 2, which is a positive 6. So when I combine these, or I add these together, I end up with 8x to the third plus 10x squared plus x plus 6. Next, I'm going to divide these two terms using long division. Now I know we could plug 213 divided by 4 into our calculator and get 53.25. However, we're going to use this process of long division today when it comes to polynomials. So let's recall what we learned in middle school. We're going to have the 4 dividing into the 213. Okay. The first thing you have to ask yourself, can 4 go into 2? Can that go into that front term of 2? And I think the answer is no. Right? It's too big. Okay? But can 4 go into 21? And I think it can. It goes into 21 5 times. So then after I figure out how many times 4 goes into 21, I multiply 5 times 4 and get 20, and then subtract. So you multiply, then subtract, and get 1. Okay, and then you do the same thing after bringing down the 3. So you say, okay, how many times does 4 go into 13? I think it goes in 3 times. So 3 times 4 is 12, same thing, and then we're going to subtract and get a remainder of 1. Okay, so this is how we're going to represent our polynomials today, 53 with a remainder of some number. But I know you probably remember from middle school that we could also represent this as 53 and then 1 over 4, 1 over the divisor, okay, the remainder of the divisor, or 53.25. So next up, we're going to use that process of long division to divide two polynomials. So we're going to set it up in the same exact way. So I'm going to take the number I'm dividing by, x minus 5, on the outside of this division symbol, and then I'm going to have the other divisor, x to the third minus x squared minus 26x plus 30. I'm going to have all of that underneath or inside of that division symbol. Okay? And then from here, we kind of go through that same process. So I say, okay, x goes into x to the third how many times? Just like we did before with, the 213 and the 4. So I think x goes into x to the third, x squared times, okay? And if you don't know that, you can always do some division. So you could say x to the third divided by x gives me x to the 3 minus 1, or, x squared, okay? And then after you figure out how many, x's go into x to the third, which is x squared, then you multiply. So you multiply x squared by x, you get x to the third, x squared by negative 5, and you get negative 5x squared, okay? And after you multiply, you subtract, just like we did before. So x to the third minus x to the third zeroes out. Negative x squared minus a negative 5x squared really is like an x squared plus 5x squared, right? Or a negative x squared plus 5x squared, which ends up giving me a 4x squared. And then when you get to here, you really just kind of have to rinse and repeat. So bring down the negative 26, and then ask yourself, what number times x gives you a 4x squared. Okay, so I think in this case, 4x squared divided by x gives me a positive 4x. And then I'm going to multiply. I'm going to get rid of these old arrows. And now I'm going to multiply that 4x by the x. I'm going to get 4x squared. I'm going to multiply the 4x by the negative 5. I'm going to get negative 20x. Once I multiply, I subtract. And you should be canceling out those front two terms, or zeroing out those front two terms every time if you did it right. So 4x squared minus 4x squared is 0, and negative 26x minus a negative 20x ends up giving me a negative 6x. And then we rinse and repeat. So I ask myself, what times x gives me negative 6x? So I think it's going to be a negative 6. So negative 6 times x gives me a negative 6. X, and the negative 6 times negative 5 gives me a positive 30. And then if I subtract those, I end up getting negative 6x minus a negative 6x is 0. And then 30 minus 30 also gives me 0. So I would have a remainder of 0 for this one. Okay? And what I want you to realize is that this, a quotient that you get out, this quotient of x squared plus 4x minus 6, because we had a remainder of 0, if I multiply that by that x minus 5, I'm going to end up with my original polynomial, x to the third minus x squared minus 26x plus 30. So next up, I'm going to do a division problem that doesn't have all the components to start with that we need to use long division. Okay, so if you look at this, front polynomial, the one we're dividing x minus 1 into, okay, I want you to notice how it doesn't have an x term. It's got a 5x to the third, it's got an x squared, but those degrees don't decrease sequentially by 1. So you need to rewrite this, so x minus 1 goes on the outside, and you need to rewrite it so that you do have decreasing sequentially terms. So 5x to the third plus x squared, and then I'm going to put in a 0x. That should have been right here, but wasn't there. Okay, so notice how I threw a 0x in, because we need those, in order for this process to work, we need this polynomial to decrease by 1 degree between each term. Okay. Alrighty, so then we can just go through that same process from before. So I can say, all right, x goes into 5x to the third how many times? So 5x to the third divided by x, I think, is 5x squared. And then I multiply. So I figure out what goes into 5x to the third, then I multiply out. So I get 5x to the third minus 5x squared, and then I subtract. I multiply, then I subtract. My front two terms, they cancel out, they zero out. Then I have x squared minus a negative 5x squared, which is a positive 6x squared, minus a negative turns positive. I bring down my 0x, and you're going to notice how it was important that we ended up adding that 0x into the picture here so this long division process works. So then I ask myself, from here, what times x gives me a 6x squared, or how many times does x go into 6x? And I think it goes in 6x times. And then after I figure out how many times it goes in, I kind of get rid of my original arrows. And then I multiply that x and minus 1 by 6x. So I end up with 6x squared, which is what I wanted. And then negative 1 times 6x is negative 6x. And then I end up subtracting. Okay? So then I'm going to subtract 6x squared from 6x squared, which ends up giving me 0. And then 0 minus a negative 6x gives me a positive 6x. And if I bring down my minus 7, I'm going to rinse and repeat here. So, what times x gives me a 6x? I think it's going to be a positive 6. Okay, so then 6 times x and 6 times negative 1 gives me a 6x minus 6. And then I subtract. I end up getting a 0 minus 1. So I end up having a remainder of 1, or negative 1 rather, for this problem. So then my quotient will be what's on the top there. So my quotient is going to be 5x squared plus 6x plus 6. And my remainder is going to be negative 1.